Welcome to This Explainer. Today, we're going on a journey into one of the most mysterious and honestly downright bizarre things you do every single night. We're going to explore the nightly activities of the human brain. Think about it. Every time you close your eyes and drift off, your mind orchestrates this incredibly elaborate, vivid, and sometimes terrifying virtual reality. But why? How does it actually happen? And what does it all mean? Well, what if your dreams, those intense, highly emotional, sometimes completely nonsensical stories you experience at night, what if they're really just your brain desperately trying to make sense of random electrical static? It's a completely mind-bending concept, right? It totally challenges everything we historically thought about the deep, hidden meanings of our dreams. So how did science actually arrive at this idea? Okay, let's dive into this. Here is our roadmap for today's explainer. First, why do we dream? Second, the brain's dream machine. Third, finding meaning in the noise. Fourth, replaying and storing memories. Fifth, reading dreams with scans. And finally, when waking goes wrong. Let's get to it.
Section 1. Why do we dream? The ongoing debate between hidden desires and random noise.
So, for practically all of human history, we've been absolutely captivated by our dreams. But when we finally started applying the scientific method to sleep, a massive debate emerged. Now, for a long time, the dominant view belonged to Sigmund Freud. His psychodynamic theory argued that your dreams are these highly meaningful expressions of your deepest, darkest, repressed desires, and they're just carefully disguised in symbols. But then, in 1977, two neuroscientists named Hobson and McCarley threw a massive wrench into that whole idea. They proposed the activation synthesis theory, which boldly claimed that dreams are, well, utterly meaningless. The activation synthesis theory completely flipped how we view sleep. To make this super easy to understand, think of the director and the generator metaphor. Deep down in your brainstem, there's basically a random signal generator. It just throws out chaotic electrical static while you're sleeping. Higher up in your brain, your cortex, which is the thinking logical part, is acting like a frantic movie director. It receives all this random static and says, uh-oh, I have to make a story out of this. So it literally stitches together memories, emotions, and random thoughts into a bizarre narrative, all just to try and make sense of the noise. Moving to Section 2, the brain's dream machine. What happens physically when we sleep? So what's actually happening under the hood when you close your eyes and enter that dream world? It's a highly choreographed biological dance explained by the AIM model. First, during rapid eye movement, or REM sleep, the brainstem activates, firing off those random signals we just talked about. Step 2 is absolutely crucial for your safety. The brain flips a switch and completely paralyzes your voluntary muscles. This is a state called REM atonia, and it stops you from jumping out of bed and acting out your dream. Finally, step 3, the cortex synthesizes those signals into the wild hallucination that we call a dream. But what makes this state even more fascinating is the chemical soup your brain is swimming in at the time. During REM sleep, a neurotransmitter called acetylcholine absolutely floods the brain. This keeps your brain just as active as when you are wide awake. But at the exact same time, your levels of serotonin, which is the chemical that helps regulate logic and mood, drop significantly. This right here is exactly why your dreams feel so incredibly real and vividly emotional, yet so completely bizarre and illogical. Section 3. Finding meaning in the noise. Why dreams feel so intensely personal. Now, you might be wondering, if it's all just random chemical noise, why do our dreams feel so intensely personal? Well, as neuroimaging got better, scientists realized the purely random noise theory wasn't the whole story. Deep-rooted biological motivations are actually at play here. When you sleep, the motivation and reward centers of your brain, specifically the mesolimbic pathway, are highly active. Your brain is essentially working in reverse. We call it top-down processing. Instead of taking in sights and sounds from your eyes and ears to build reality, your brain takes your internal fears, desires, and memories and projects a reality from the inside out. Which brings us to Section 4, replaying and storing memories. How dreaming makes us better at waking life. This leads to a massive breakthrough in sleep science. It turns out, dreaming actually makes us better at waking life. It's not just a nightly hallucination, it's an essential biological tool for sorting, processing, and permanently storing the memories of what happened to you that day. To prove this, Dr. Erin Walmsley and her team conducted an absolutely fascinating experiment. They had people navigate a specific virtual maze on a computer. After practicing, some participants stayed awake while others were allowed to take a nap. The sleeping participants were then woken up periodically and asked what was going through their minds. Some reported they were actively dreaming about the maze, or maybe the music in the maze, or even exploring a virtual cave. So the crucial point is, the results were absolutely staggering. When the participants were tested on the maze again later, the ones who had stayed awake, they didn't improve much. But the participants who took a nap and actually dreamt about the maze, they showed a 10-fold improvement in their performance compared to the sleepers who didn't dream about it. 10-fold! The brain was literally practicing and strengthening the memory of the maze while they were completely unconscious.
This shows us that dreaming has incredible waking life utility. It gives us huge evolutionary benefits. It consolidates our short-term memories into long-term storage. It acts as a cognitive cleanup crew, literally sweeping away useless information. It lets us subconsciously problem solve without the distractions of the waking world. And according to the threat simulation theory, those stressful nightmares you have, they're actually a safe virtual reality training ground for your brain to practice surviving real-world dangers. Moving right along to Section 5, reading dreams with scans. Can science literally read your mind?
Okay, so if the brain is doing all this incredible visual processing at night, it begs a total sci-fi question. Can science actually see what you're dreaming? Well, in 2013, researchers led by Yukiyasu Kamitani started using fMRI machines to literally peer into the dreams of sleeping subjects. By monitoring their brainwaves as they slept, and then waking them up to ask what they were dreaming about, a computer learned to recognize their neural patterns. Eventually, just by looking at the brain scans in the 9 seconds before the person woke up, the researchers could predict whether the person was dreaming about a car, a man, a woman, or a computer, with 75 to 80% accuracy. No way, right? The reason this works is actually pretty simple. Your brain uses the exact same machinery to dream as it does to see. If you're wide awake and looking at a real car, specific higher-order visual areas in your brain light up. Now, if your eyes are squeezed shut in a pitch-black room, but you're dreaming about a car, those exact same visual areas light up in almost the exact same way. To your brain, the dream is structurally as real as waking reality.
Section 6. When waking goes wrong, the terrifying reality of sleep paralysis. Because the dream world feels so incredibly real to the brain, things can get genuinely terrifying when the transition to waking up doesn't go smoothly. Put simply, sleep paralysis is a biological glitch. Remember that safety switch we talked about earlier? The one that paralyzes your muscles so you don't act out your dreams? Well, sometimes your conscious mind wakes up, your eyes open, but that safety switch hasn't flipped off yet. You are fully awake and aware, but entirely paralyzed.
And because your brain is caught in this mixed state between REM sleep and wakefulness, the dream generator is still running. It's projecting rich, terrifying hallucinations right into your real bedroom. People typically experience 3 genuinely frightening types here. The intruder, which is the terrifying sense of a dark, evil presence in the room. The incubus, which is a feeling of immense, suffocating pressure right on your chest. And vestibular motor hallucinations, which basically make you feel like you're floating or having an out-of-body experience.
Now, if you've experienced this, it is genuinely horrifying. But I want to reassure you, while it feels deeply supernatural, it's strictly biological. We know exactly what triggers this glitch. It's highly linked to poor sleep hygiene, like severe sleep deprivation and irregular schedules, as well as high stress, anxiety, and hypertension. It's not ghosts, guys. It's just your brain's chemistry temporarily misfiring under pressure. Let's bring it all together and see how this builds the nightly journey of the brain. Every single night, your brain undertakes a truly spectacular journey. It takes random chemical noise from the brainstem, locks your body down in a state of paralysis for your own safety, and acts as a master storyteller. It weaves your recent memories, your deep motivations, and your daily anxieties into a virtual reality that literally wires your brain to be smarter and better equipped for survival the next day. So, I want to leave you with this final thought to ponder tonight. If our dreams aren't just random static, but actually a vital active process where our brains replay, remix, and process our lives to help us survive and thrive, what puzzle is your mind going to solve tonight? Thank you for joining me on this explainer, and until next time, sleep well.